Hi guys, this is Enrico from Jaranga. In this video I'll show the AUBO i5 with a small control box being connected to the Robotiq FT300 Force Sensor and the Robotiq 2F85 two-finger gripper. Okay, so how did we do the setup here? From a mechanical setup or wiring, so you're mounting the Force Sensor first, and then we're mounting Robotiq gripper to it. It's identical adapter plate, so it's just mirroring the one from the robot. Then we wired the serial communication and power supply cables to the control box, and then we have here two serial to USB adapters, which I show in a moment how they are connected. Yeah, we're actually going around here and then going into the USB ports on the control box. Okay, let's look at the components a little bit closer. So again, here we can see from this is the robot tool adapter, and then we see the force sensor onto this line, and then we have a Robotiq two-finger gripper. The Robotiq sensor, the force sensor, when it's working and running, there is here around the cable is an LED, which will be blue when it's running and sending the data. And then for the Robotiq, we have the LED here, which is at the moment red, which will only be blue when it's moving, and it will be red when it's not moving. It does not mean that there is an error in the gripper. Just so there is no confusion about that. Okay, let's look at the wiring I just mentioned. We use the USB serial connector. So here we see the cable coming in from the robot from the force sensor, and here on the bottom we see the cable coming in for the gripper. Okay, what cable wires do we have? We have white, green, and then we have a silver grayish one, which is actually an unisolated cable. And then we have here a black one and a red one, and the same we have for the other one. So green and white is for serial communication. The silver one is ground, which is the shield of the cable at the same time. And then we have black for 0 volt and red for 24 volt. So we are connected to the 16XT5 connector, which is a sole power supply connector, so where you can connect sensors and grippers in this case and force sensors. So how does this one work? We see here is a plus symbol, there's a minus symbol, even though this is not super sharp here in this picture. There is a bridge which is using the internal power supply plus 24 volt going to these 4 pins. And then we have a minus the internal power supply 0 volt going to these 4 pins, which means under the bridge the first 4 pins are 24 volt, and on top of the bottom bridge the top 4 pins can be used for 0 volt to connect sensors or anything. So we see here black and black to 0 volt, red and red to 24 volt. Okay, let's look at the software side. I make the picture smaller, and let's look at the gripper in case we move it in a small window. Okay, so here we have a AUBO PE software, which is running right now. We find our configuration under extensions, which is here, and then under Robotiq 2F, and then we have a settings for the configuration. AUBO is putting for plugins. In case you don't have a plugin, it can manually add it to your software, depending if you have a right software version. Here we are talking about the 4534 in this case. Actually, there is one higher level 35, which we should probably use since they solved some bugs. Anyways, we go back to extensions, and under about there is a manual with some details and how to use it if you need to check. There's also the assembly of the gripper. Here it shows a 2F85, but it's identical to the 2F140. Here we see the wiring plan, which is not completely correct, which is an older version. White is still white, red and black are the same. Blue is actually green, and gray is the silver unshielded ground cable. It's very similar, so it shouldn't cause any confusion. And then you see here the description of the interface and so on. So if you have any questions, look at about section first. If you don't find anything, feel free to contact us. Okay, then we go under settings. If you are running a single gripper from Robotiq, which is a two-finger gripper, it can be the 2F85, 2F140, or the HandE, which is a parallel two-finger gripper. All Robotiq components as a background, even the force sensors, they are all sent out with a slave ID 9 as a product. Okay, what is a slave ID? What it's used for? In a network of serial communication, or in a system of serial communication, which we have here, it is possible to talk to multiple devices or components but you need to know which one you're talking to, and you have to differentiate them somehow. So for this one, it is used the slave ID. If you have two devices with a slave ID 9 in the same system, you're going to have a problem. So here we exactly have that. We have a force sensor with a ID 9, and we have a gripper with ID 9. Unfortunately, in Robotiq, it is not possible to change the ID for the force sensor, which means we have to change the ID for the gripper if we want to use both systems with serial communication. If you use different communication networks for both of them, then you can keep the same ID. Okay, so since we only can change the Robotiq gripper, we used the RUI software, which is, you can download it from the Robotiq website. It stands for Robotiq User Interface. You connect the gripper to your notebook or PC via USB. You need an external power supply, and then you can go in. There's a manual on Robotiq where you can go in and change the slave ID, which I did on this gripper here, and I changed it to slave ID 10. Okay, done. Okay, then we have to select the port where the gripper is connected to. If you only have one device connected, there will be only one which is automatically selected, then you don't have an issue at all. However, let me jump back one window and look at the control box. We have here two USB ports. This is number 1 and number 2, or internally called USB 0, USB 1. It is absolutely necessary, if you want to use the force sensor, that the Robotiq gripper goes onto the USB 0 and the force sensor on the USB 1. There is a bug in the software, which I think they missed. Let me change back from the screen. When you are using the gripper and you're actually selecting here USB 1 and you press connect, it jumps back to USB 0 automatically. Therefore, it would try to connect to the force sensor if it's plugged in into that port. And maybe to your surprise, it will have a successful connection. The reason for that is that as long as you don't try to trigger any registers in the background, the base communication between a force sensor, so the serial communication between the force sensor and the gripper, there is no difference. So that's why the interface can actually connect on that one. Yeah. However, if you try to run the gripper, then it's not going to do anything, and your force sensor is also not going to work. Okay, so again, top port in the control box, USB 0. I changed to slave ID 10. If you didn't change, it's not going to work. Otherwise, it will be 9 by default on the gripper, so you need 10. If you did these two, we can press on connect, and then we should be fine. We see here gripper is connected. Okay, let me change the camera screen back that we can actually see the gripper when I activate it, because it should close and open the gripper once to the maximum position. So let's press activate. Okay, closing, opening. Okay, perfect, works, communication works. Here on the left side, regarding the serial communication, unless you made any changes there, which you don't have a reason for, in general, there is nothing to change for you. Then we have a control section. So this is the Robotiq 2-finger gripper. Here on the screen, on the top right corner, has 3 options you can adjust. Since it's an electrical gripper, you can adjust the position you want to move to with a slider. This will go from 0 to 255 because it's a register. So there is not linear positioning. So you cannot say, if I go halfway, the gripper opening is going to be exactly halfway. That is not a linear translation between the position of the motors and the gripper. So you would have to test what you need for your positioning, at least when you run it this way with AUBO. Then we can do a force setup. I set here 30. Again, this goes from 0 to 255 from the scale of a maximum force. In that case, it is linear. And then we have a speed as well, which you can find. It depends on which gripper fingers you have mounted, like a 2F85 and 140 or the HandE, and what means what exactly. So you have to look into the manual for the reference. Okay, so how do I check or activate this thing? So there is an action button on the bottom, and I press it. The gripper should move, as you can see, to the position we set. We used speed 211, so it's quite fast. So we can see this easily. If I use the slider to a different position, action, it's going to move there. Okay. Then beside these buttons for using the slider and the action button, you can also open fully, you can close fully. Let's go back to action, and you can use on the slider side the plus and the minus button. This will trigger right away. It does not require to do an action button. So if you want to test the gripping force on the piece or the gripping position, you can then go step by step in the system. You see it's closing step by step while I'm pressing it. When I stop, it stops, and I keep pressing it. Yeah, so these one directly trigger the movement and the action. The sliders are going to be changed and be triggered by the action button. Okay. Good. Since we didn't change the position, it didn't move just now. Okay. Block control is supposed to allow two different functions. Let's assume you are calling a signal twice, once, and then you send a second command after it, but the first command is not finished moving yet. And non-block control, in theory, as soon as the second command comes or the second action comes, it will directly abort the first action and execute the second one. If you use a block mode, it will finish the first command and then send the second one. I haven't tested this one yet successfully, let's say it that way. It might be I just saw that this is not the latest AUBO PE software version. I may have to test that again and see whether this is the same thing with the latest version. Just leave this out for now. Sometimes there is some things, if they are not used a lot by people, they actually don't work as they should yet. We will take care to keep an eye on it and then do some upgrades with AUBO there. Okay, this is so the main configuration and the setup for the gripper. When we go under program, I just made a small program. I put a waypoint in, which is the current robot position, just that it has a reference and starts the program. And then I have two gripper positions here and here. Okay, how did I do that? So let's delete this one. And again, so we have a loop here. We want to loop 5 times. And then we go under peripheral here, which allows us to access the 2-finger gripper plugin. When we have the gripper, we have to select it, select the ID, which is 10 for this configuration, and then we can adjust here positions, whatever we want. So let's do 200, but we can see something. Okay, we don't need much force for this application, and we want to have a little bit more speed, but we can see something. Okay. Confirm. Okay, this is working. If you want to see where this actually is, you can press Control Gripper, and we see here it's nearly closed. And then we go on peripheral again, do another one, do the selection again. Oops, do the selection again, do the ID again, and then the ID here is necessary because theoretically you can run 2 grippers on a dual. I haven't tried 2 grippers yet. I might try this in another video. This one is for the force sensor and the gripper in combination. Okay, when we do a position 0 is fine. We do 30 on the force, and we do faster movement. Okay, confirm. This works. Control the gripper. Okay, fine. Project and save. Okay, and then start the program and run it. Okay, so we see, since we are looping, I think we are looping 5 times. The gripper then should be opening and closing without any issue there. Okay. Good, then the program is finished and we are done. Great. Oh, actually we saw that the signals were queuing up just now. Okay, interesting, haven't seen that before. So as I mentioned, there might be an update required soon. However, the basic function of the gripper is working right now. And if you use the gripper in the system, you should always use a wait time after anyways to make sure that your movement is successful and done. Okay, so this is only the first setup. This is the 2-finger gripper, but we are talking about the force sensor as well, which we see mounted on top of the gripper. Okay, where do we find the force sensor? So we decided on this force sensor to do a Modbus RTU communication, which is also a serial communication on Modbus. There is the option to use a TCP communication, which is via Ethernet, so network cable. We are using RTU. This is a function where you can use the force sensor. However, this is not the recommended version to use this gripper by Robotiq because the maximum speed the force sensor can achieve of sending you the data is actually by a function which is sending a data stream on the serial communication. But we don't have any module at the moment in the standard AUBO PE software to support that. And for most applications, it will be enough what we can do via Modbus RTU. However, if you have an application where you run into a bottleneck regarding update speed from the force sensor, when we need to change the communication and use the serial data stream. Okay, what did we do here in the setup? So I defined an FT300. I used the slave ID 9. Like I mentioned earlier, I cannot change it on the force sensor. I do a response time of 50 milliseconds and I do a frequency of 50 Hertz, which means we are updating every 20 milliseconds, which is more than enough, which is actually faster than the AUBO PA application is executing most of the jobs anyway, so we should be fine with that. Then we selected the device. You see here is USB 1. It's important. This is plugged into the lower UCB on the front of the control box, which is in this case for the small box is the top side. And then we have a baud rate 19200 data bits, stop bits, and no parity. Okay, good. We add this one, and then we go to the I/O config. Here in the I/O config, you can see the addresses I used. We use registers output based on the manual. This is this one with communication codes 0, 3, and 10. They work, and then we have addresses here in hex code behind that. So what do we have? We have the acceleration in X direction, acceleration in Y and Z direction. Then we have a force in X, Y, and Z, and then we have a momentum around X, Y, and Z. I added one more register to check the year of the force sensor. Why am I doing that? So theoretically, in a resting position, which doesn't really happen, but theoretically you could have all forces, momentum, and acceleration 0, which is also what happens if you lose the communication for whatever reason. They are by default 0. So if you use these data, it makes sense to do some form of checkup. If you are reading the year, which is a fixed value and will not change, if it ever drops to 0, you know that your communication is lost and you can actually react to it in your software. Okay, let's look at the state. We go here to the I/O state on top, and we can see here the current live data from the force sensor. We see here on the bottom the year 2020. So this is where our demo unit was built. And this one is going to be always the same and static. We see first row accelerations, then the forces, then the momentum. How to use these numbers and how to use it in the software is going to be a different video at a later stage. Okay, good. This is only, there's more registers we can actually use on the force sensor. However, if you really do an application, that's all you should need on the robot side. Probably you wouldn't even need all of them. Okay, good. If you have any questions, let us know. Again, most important part, let me just to make this big again and make sure that this is completely understood. These USB from the serial connection, this is what I call USB 0. This has to be the gripper in the configuration I've shown to you. This on the bottom has to be the force sensor. You both have to be connected to power. And most importantly, to make it work, the gripper has to be changed to a slave ID, which is not 9. I changed 10 to 10. You can use any other one you like, just to make sure that the system works. Okay, thanks.